Okay. Let's look at the question first. So if you look at the question, you will see. So let's, rework on the facts which are given. What are the facts that we have? We have CD is parallel to AB.
Yeah.
We have CD is 2 by 3 AB. Correct? We also have AB is the diameter, so 2R. Right? So what is CD?
Yeah.
2 by 3 into 2R, that is 4R by 3.
Yeah.
Correct? Now,
Yes.
so basically, if we have to draw, and they have asked you what is the distance between the chord and the diameter in terms of R. So if you have to find out the distance, then it has to be something like this. This distance is what they are asking.
Yeah.
Right? Either this, or since it says that what is the distance between the chord and the diameter in terms of R, what is this? Yeah. So R, 4R by 3. We need to find this out, right? CX. Yes or no?
Yeah.
Right? So in order to find out CX, what we have done is we have dropped a perpendicular from the point C on the radius AO, which is, and this perpendicular is meeting at right angles at X. Correct?
Yeah. Okay.
Very good. Now, after this, if we look at, let's say, CX. CX. Let's say this is X, for example. I mean, we are
Okay.
just assuming that this
Oh.
perpendicular distance or this perpendicular length is X,
Yeah.
right? So, sorry, this X, this one, OX is equal to CX. Yes or no?
Yes,
OX
ma'am.
to CX. And what is OX doing? OX is basically bisecting CD. Yes or no?
Yeah.
OX is basically bisecting CD, right? So if
Yes.
OX is bisecting CD, that means now CX is equal to XD equals 2R by 3, correct?
Yeah.
Talking about this portion. Talking about this portion. Like if I can draw it in a better way, it is something like this, right?
Yeah.
This is C, this is D, this is the chord, this is the center, this is the diameter AB, this is your radius, right?
Yeah.
And this is that perpendicular X. So any
Yes.
perpendicular which is basically drawn from the center of the circle to the chord will be bisecting the chord at right angles. Yes or no?
Yeah.
Right?
Yes.
So this is our, we know. What is
Yeah.
CX? CD is 2 by 3 AB.
Yeah.
2 by 3 into 2R. 4R by 3, where R is the radius. Now, since OX is bisecting CD at right angles, so CX is equal to XD is equal to 2R by 3, bisecting by 2, correct?
Yes, ma'am.
OX
Yeah.
we are assuming to be X. Suppose we are assuming that OX is X. Make sense?
Oh. Yeah.
Correct. So now, isn't this a Pythagoras, isn't this a right angle triangle OCX, where OC is R, OX is X, and CX is 2R by 3. See? Yes or no? CXO? Yes or no?
Yeah.
Right? Perfect. So now we can
Yes.
apply Pythagoras theorem over here. This is a right angle triangle.
Yes.
So OC square is equal to OX, which is X. So OC square is the hypotenuse. OC square is equal to OX square plus CX square. Yes, which is R square, X square
Yeah.
plus 4R square by 9. Correct?
Yes.
2R by 3 whole square. So this is R square minus 4R square by 9, which is X square. X is 5R square by 9 root over, which is root over 5R by 3. So the answer
Yeah.
should be root over 5 by 3 dot R. In terms of
Yeah.
R is what they have asked, no? So I think D should be the answer. Make
Yeah.
sense, Dakya?
Yeah. Yes. Yeah.
So what is the takeaway after doing this particular sum? What is the concept that we are basically using in order to solve this complex geometry problem?
Mm.
What did we do? This was
Pythagoras.
a complex one, yeah.
Yeah.
See, we basically had to make that right angle triangle, right? In order to find out the
Yeah.
value of 2x.
Yes.
They had given us the details that AB is parallel to CD. CD is half of 2 by 3 of AB. And then we had the
Yeah.
radius in terms of R. So we basically
Yeah.
had to find this out, right? OX. So if we had to find out OX, we had to form this right angle triangle CXO. Use the details, then work with the Pythagoras theorem to find out the answer, right? So this is a little
Yeah.
bit complex because 2-3 concepts were kind of interconnected.
Yeah.
Got it? And the major thing that we
Yes.
used is if we are dropping a straight line, a perpendicular from the center of the semicircle, then that is bisecting the chord CD at right angle. Make sense?
Okay.
Yeah.
Yeah. Yes, ma'am.